You're most welcome. Before we can be able to see the blackboard, we have what we are calling the Mercury cathode cell. This is the one that we say that we shall come back and look at it. Normally used in the manufacture of chlorine and sodium hydroxide. So we want to see how we can be able. Remember last time we listed the raw materials for the manufacture of chlorine gas, and one of them we talked about brine or concentrated sodium chloride solution. Now the one we talked about, this is the vessel that we said, and we shall be able to use this. We are going to introduce here sodium chloride solution. We see how it can be introduced. Sodium chloride solution is introduced from this side. This is what we are talking about brine in. You are introducing in concentrated sodium chloride solution. Now this Mercury cathode cell, it has this, and this is what we call the graphite anode. Graphite anode. This, which is connected to the power source. It is connected to the power source. Then at the end of it all, we have introduced this. But what is this? This is what we are calling, it is connected to the cathode. But at the end of it all, it is also connected to the power source. Of course, for electrolysis to take place, we need electricity. All of the electrodes have to be, both the cathode and the anode have to be connected to the circuit, the electric circuit, and then after they will be dipped within the what? Within the solution. So all of them will be in the electrolytes. Now, at the end of it all, we have brine. Now this brine that we are introducing, down here, we shall have a layer. This is a layer of mercury. That's why we say the mercury cathode cell, meaning mercury is being used at the cathode. Okay? So this is what we have, mercury here, and that's why this one is connected at this point up the power source and moves from the cathode. Then when you introduce brine, this one here, it will be at the surface. We have brine that we're introducing, or we are introducing what we are calling concentrated sodium chloride solution. So there is a layer separating both of them. There is this layer that separates both of them. It separates the mercury, and it is also separating concentrated sodium chloride solution. Now, during the reaction, just like we looked at it last time, we said that concentrated sodium chloride solution, dissociates in solution to give sodium ions and chloride ions. But since it is a solution, it also contains water, of which water is a weak electrolyte, and it is slightly ionized in solution. Slightly ionizes in solution to produce hydrogen ions and hydroxide ions. That's what we talked about water, and we said that when we are dealing with this, both the positive charge and the sodium ions and the hydrogen ions will migrate to the cathode, and also the chloride ions and the hydroxide ions will migrate to the anode. However, the ion that is highly concentrated and the other will be discharged. In this case, when you go to the anode, like when we are manufacturing chlorine, as we said, chloride ions will be preferably discharged because they are more concentrated than hydroxide ions, and that's why chlorine gas will be formed in this case. When chlorine gas is formed, it is released from here. This is chlorine gas being released from here, and then this one allows you use the brine. Use the brine to be out. This one here. Then this one here will also allow sodium amalgam to move out. This sodium amalgam that we are talking about is as a result of sodium formed at the cathode reacting with the mercury. When sodium reaches at the cathode react with mercury, we form what we are calling sodium what? Amalgam. So this one, sodium amalgam, will be released and it will be poured into the water, such that when it reacts with the water, it forms sodium hydroxide solution. So this is what we are calling the mercury cathode cell that we say that we shall explain in details. It has the graphite as the anode, it has the cathode, but all of them are connected to the power source because the electrolysis needs electricity, and at the end of it all we introduce here prime, whereby mercury is being used at the cathode. So the electrolysis takes place. We have said that sodium chloride dissociates in solution to produce sodium ions and chloride what? Ions. Meanwhile, water is also a weak electrolyte, and the one that is used to make sodium chloride solution, it will produce hydrogen ions and hydroxide ions. But sodium ions and chloride ions are more concentrated than hydrogen ions and hydroxide ions, though all the positive charged ions will migrate to the cathode and all the negative charged ions will migrate to the anode. But chloride ions and sodium ions will be discharged at the respective electrodes, both at the cathode and the anode respectively, because they are more concentrated than hydrogen ions and hydroxide ions in this solution. That's the mercury cathode cell that we wanted to look at. We call it the mercury cathode cell because, of course, we are using mercury as the cathode. So it is being enclosed from down. That's why we have the mercury cathode cell. So we shall continue from there next time. When we proceed, we are most likely to look at the manufacture of sodium hydroxide, and we also see what happens at the cathode, because last time we looked at what happened to the anode. If you missed that, you can cross check. There is a video which shows on this channel. On this channel there is a video which describes, or what that explains. I was explaining the manufacture of chlorine gas using the mercury cathode cell. However, I didn't go ahead to draw the mercury cathode cell, and I promised to come back and explain it, and this is the one that he have explained.